our next program will start with another speaker from Netherlands. He's from Little Robots. I just learned that we played together in a band, but I don't remember that because I was like involved in some other activities like drinking. And Hugo Visser from Netherlands.
Right. Well, thank you. So I'm Hugo. I'm an independent Android developer. Little Robots is my company. I'm also a GDE for Android. And today we're going to talk about Room, not like the room, but the new object persistence library from Google, which for that reason I call the blessed object mapper, because until now there wasn't really an official thing. Before we dive into Room, let's have a quick recap about Android persistence. So basically, if you want to store stuff in Android, you basically have two options. So you either store small amounts of data in your shared preferences, but yeah, that's only suitable for settings and very small amounts of data because it's stored as an XML file. For any serious amount of data, you probably want to use a database, and Android provides a SQLite database implementation for that. But the SQLite API is not really the nicest one to use. It's kind of verbose. You are typing raw SQL into strings, which can lead to typos and all kinds of runtime errors. So over the years, a couple of object persistence frameworks have popped up to make this easier for you. And there are basically a lot of those. And these split into two groups again, the ones that actually use SQLite underneath and the ones that don't. So they are basically NoSQL solutions. An example of that is Realm or ObjectBox. For the SQL-backed solutions, there are still a lot of options. I listed a couple of popular ones. I think SQLite is probably pretty popular. Green DAOS has been around for a long time. We have dbflow, and I've also written my own called Cupboard in the past. And what these frameworks typically do, they give you some kind of API to work with SQL in a way. So they either abstract it a little bit to make it easier for you to work with it and don't make any typos, or they move to full SQL just to be as pure as possible. So the type of framework that you pick basically depends on how comfortable you are with SQL usually. So if you look at SQLite, everything is SQL. You define your tables in SQL, you define your queries in SQL, and then it generates code to actually work with these queries. So there are little no abstractions there. It's all SQL. When I looking at my Cupboard framework, it takes another approach. It doesn't really let you do all the advanced things that SQL allows, but it also hides a lot of SQL for that reason. So in Cupboard, we're using SQL mainly as a fallback. Room is somewhere in between. Room does use full SQL for all the querying and migrations, but it doesn't use SQL for table creation. So that's under the hood. So working with Room, you do need to know some of the SQL, mainly the query and the data modification language, which is actually, I think, a good thing because SQL is like meant for these things. So some key points about Room. It's part of the Architecture Components initiative, and the Architecture Components consist of a guide that tell you how to write Android apps basically in an opinionated way. It's just a guide, so you can also deviate from it, no problem, of course. And it also consists of a couple of components that help you implement that architecture. So Room is one of those architecture components. Room by itself does not allow you to store a big object tree in the database with relations. That's kind of important to note. There's a good reason for this, because when you are storing relationships like that, you have an object tree, at some point you need to fetch all the related objects, and especially if you are doing this on the UI thread, all kinds of performance issues may happen, and you may cause jank in your app. So Room, like other frameworks, takes the approach that we don't have these lazy loaded kind of relationships, also protecting you from doing bad things with regards to performance. So, like I mentioned, all the database operations use SQL. There are no real abstractions there. And currently, it's on version 1.0, release candidate 1. Ooh. Which means that we're almost ready for release, and that's probably bound to happen very soon. Another, I think, pretty important point is that Room is created by Google, which means, especially for me as a freelancer, it might be easier to get this into a project because, yeah, it's backed by Google. People eventually will know this standard framework, and it's easier to convince people to use this. And it's also likely that Google will have a little bit more manpower when it comes to tooling, integrating this to Android Studio, all kinds of things like that. So in that sense, it's pretty important. So how do you get started with Room? It's pretty simple. Like any library, you need dependencies. For Room, you actually need a couple. There are two main ones. There's the runtime dependency, and there's an annotation processor. So as of Android Studio 3.0, you use this syntax for that. So your implementation will be the runtime, and the annotation processor specifies the Room compiler, which actually takes your code and generates other code for you. You're likely to use some other architecture components as well. Mainly live data, that would be the main one. And for that you need to have a recent support library version and also the lifecycle extension component with the annotation processor. Another key thing that you need for working with Room is you need to specify some annotation processor arguments, because by default Room will try to generate a schema of your database and will try to output that in some location. And if you don't tell it what that location is, it will just not compile your code. So in practice, you really need that annotation processor option here, which will tell you where to export the schema. And this is important. We'll come back to that later. If you're like using Kotlin now, Kotlin is just as easy. You just apply the Kotlin cap plugin. It's important that you apply this plugin and not rely on the standard cap or the old cap version. Because Room doesn't really work with that. But otherwise it's pretty much the same. You have your dependencies, and instead of annotation processor you use capped. And for the arguments you have a slightly different syntax, but it's basically the same thing. And again, you need that to specify the schema export location. So I mentioned annotation processor a couple of times. This means that Room will generate code for you, but it will also do compile time validation of your code. So it will check SQL queries and will tell you when you have made a typo, which is actually pretty great, because otherwise, with a lot of frameworks, but also when you're writing your SQL code by hand, you will find out at runtime, and worse, you probably find out when some user runs into this problem. It also means that there's the least amount of overhead at runtime, because all this code is generated. There's no reflection of that kind of stuff. Room consists of basically three ingredients. So you have your entities, which are your model objects. We have our data access objects, which allow us to work with that object. So it defines how you store or retrieve objects from the database. And we have the Room database component that basically ties this all together and specifies where you are actually storing all these entities. So we go into this components now. Now let's first start at the beginning, of course. So we have our entities. An entity is basically just a simple Java object that you annotate with the entity annotation. And when you annotate it with the entity annotation, in this case, Room will store this object into a user table. Because the class name is user, Room will by default pick that name as the table name in the database. So you need the entity annotation, but you also need the primary key, because every object in the database needs to have an identifier so that you can uniquely identify that object. So you can specify the primary key using the primary key annotation, and you just slap it on this long ID in this case. And you can also tell Room to auto-generate that ID, which is pretty convenient. But in many cases, a long ID isn't that convenient, so it can also be a string. And if you try to do this and then compile this code, Room will automatically validate your schema and will say, hey, this isn't working for me. If a primary key is annotated with auto-generate, I don't know how to generate it, basically. That's what this error will mean. Well, sure, we can fix this. We can just leave off the auto-generate in this case, and then try again. And now if you compile this, Room will again validate your entity and will say, well, if you have a primary key which is a string or some other, or a string basically, then you should make sure that it's never null, which makes total sense, of course, because if you have an identifier which is null, how can you identify that thing? There's actually a bug introduced in older versions of SQLite that allowed for a null primary key, but it is like bad practice and we shouldn't do this. So let's fix this. We annotate it with non-null, but now we get in this situation that, because it's non-null, we need to make sure that it's actually always initialized. And what's nice about this non-null annotation is once you annotate it with non-null, Room will also make sure on the database level that you are not allowed to insert any null, so it will be a non-null column as well. So now in this case we have our user, we have two constructors, one that takes an ID and the second one that generates some ID so that you can insert something new. The only problem here is that now our entity is kind of a Frankenstein of mutable and immutable properties, so let's fix that. Well, now we make the first name non-null because like a user without a first name, doesn't make sense. Add another constructor, add some getters and setters, and this would be like a proper entity in Java code. And if you're already using Kotlin, you probably know where this is heading. In Kotlin, we have data classes which take a lot of this ceremony out of Java beans. So the good news is that Room also understands these Kotlin data classes. So again, you annotate it with entity. Because it's mapped with entity and the class name is user, it will store it in the user table. And then you just specify your primary key again. You can give it a default parameter in this case, default value. And you give a first name and last name. And if you are already using Kotlin, this wouldn't be that surprising, but you'll notice that there are no non-null annotations anymore because in Kotlin this is built into the type system. So we know that the ID and the first name are never null, and we know that the last name might be null because it has a question mark on the type. So Room just understands this and will generate the exact same schema. So this is your basic entity. There are some extra options you can specify on the entity notation. You can specify a table name, for example. I wouldn't really advise to do that because it makes mapping from a query to an object harder. If you just keep the same names, then you can say, well, if I'm querying users, then I know it will be coming from the user table. But if you have some reasons to rename that table, you can. There's also an option to specify the primary key in a different way. In this case, we have a composite primary key, so the primary key consists of multiple fields. And Room just allows this because it's possible in SQLite as well. There are more things that you can specify. You can specify your indices. So to optimize database performance, you might need some indices. And you can do that in two ways. You can specify it on the entity annotation, or you can use the column info annotation, which also allows you to tweak the column representation in the database further. So if you just have a single index, you probably want to use the column info, set index as true on a single field to make it indexed. And again, with the column name, you can also rename the column name in the database, and you can set things like type affinity and collation, which is important if you want to query on it, depending on how the database is basically comparing your column to your value. So this is pretty powerful. So to sum up the entity part, they're basically annotated Java or Kotlin classes. They must specify a null primary key. And you can see that the representation in the database of these classes is highly controlled by annotations. And it's very flexible as well. One thing to point out is when you're looking in at the documentation for Room, for example, you'll notice that sometimes they talk about entities and sometimes they talk about POJOs. And they might look the same, but they really aren't. There's an important distinction here. An entity is something that you store into the database. So it's an object that has a table associated with it. While a POJO is something that you map any result set on. So a POJO is not necessarily associated with a table, but associated with a result, with a query result, basically. And we'll see how that works in a second. But it took me a while to actually make that connection because it's not really explicit in the documentation that this distinction exists. All right, so we have our entities, we have our data model. How do we go about storing these entities or retrieving these entities? For that, Room allows you to specify data access objects, or DAOs. They define the methods of working with entities, and they might be abstract classes or interfaces. So it's not something that you actually implement, it's something that Room will generate code for. So somewhat similar to if you are using with retrofit, for example, you have this interface and you tell them, well, I want to get this, this object from this URL. Room is kind of similar. And you can have one or many database objects, access objects in your project. So depending on how your model is or how your business logic is organized, you might have more than one in your project. This is an example in Kotlin for a DAO, and we're using the query annotation here. But as you can see, it's pretty simple to define it. It's pretty similar to things like retrofit, as I mentioned. You annotate your interface with the DAO annotation, and then you just have methods that express what you want to do with your data. So in this case, for example, let's get the first user from the database. You see, you just specify a method that returns a user, and you annotate it with a query annotation that actually holds the SQL query. So in this case, select star from user, limit by 1, which means just any first user that we can find. If you are doing this in Java code, then Android Studio will currently also check and autocomplete any arguments you have in that query annotation. So it will autocomplete the user and that kind of stuff. If you're using Kotlin, not so much. I hope that's still coming. It probably is. But the important part here is that when you compile this code, Room will actually check this query. So if you don't have a user table, it will tell you at compile time. So some other examples, you can, of course, get a list of users. So you can just specify, give me a list, select star from user in this case, or give me your first name. And Room knows that this first name is something that it can map on a string, and will just give you a list of first names in this case. You can also specify some query parameters by binding to it in the query. So you can see in this find users by first name, we have this fn parameter, which maps on the fn binding argument in the SQL query. Also interesting to note that query doesn't mean you actually need to write selects. It can be any SQLite statement as long as it returns some kind of a result. So it can also be delete, for example, like we have here. And the last example is where we map the result onto a POJO by basically renaming the first name column to first and the last name to last, and then specify that we want a list of persons. And the reason why we are renaming this is because the POJO, in this case, doesn't have a first name and last name field, but it has first and last. And by being creative in your SQL query, you can basically map any result set on any Java or Kotlin object. And you also note, like I mentioned before, this is not an entity. You can't really store a person in the database, but you can map the user result back on the person object in this case. And Room will just match the column names, and it must be able to convert whatever is in the column back to your POJO as well. Yeah, so we have query. We also have ways to insert things, of course. Insert is pretty similar. For insert, you can specify the conflict resolution. So by default, it will throw you an error if this object already exists, or rather, if the primary key of this object already exists. I think it might be common to override the thing that you are storing. So if you have a user or existing user want to update it or override it, you can just set the conflict strategy. And what's important to note is that every operation that you annotate with insert is run in a transaction. So if you have a list of users that you're going to insert, it will be run in a single transaction, so you know this update will be atomic and either everything works or everything fails at the same time. Insert can return you the list of row IDs. I don't think it's that useful, especially if you're using string primary keys, but it can do that. And you can also combine multiple types of entities to insert in one go in one transaction by just adding more parameters to your method. Well, delete, it's getting kind of boring from here. You can just delete a user that does need to have a primary key set. And again, this runs in a transaction, so if you're deleting multiple users, that will also run in a single transaction. And same goes for update. By using these data access objects, we can do some interesting things. I mentioned that entities do not allow for object graph storage, so you can't really expect to have a user with books and then store it in a database, and then everything will be working as you might expect. We can still model this though. So I've done this in this case. I have a user, and a user has a list of books. And if I would only have the first constructor and try to store this or compile this even, then Room will complain that it doesn't know how to store this relationship to the books. But we can add a second constructor, initialize that with an empty list, and then tell Room a couple of things here. We can say, well, you need to use the second constructor. So a little bit counterintuitive, you need to ignore the primary constructor. So by ignoring the primary constructor, Room will default to the second constructor that we have defined. And then we just also need to ignore the field that is generated for the books. So yeah, don't create a column for that, it doesn't make sense. So again, ignoring the constructor and ignoring the field, that is sufficient for Room to be able to store this entity without the list of books. But we still want to store a user with his books in one go, right? So what we can do, we can have an abstract data access object class. And these abstract classes are very powerful, and this is just one single example. Again, we have an abstract class, we annotated with DAO, then we have the inserts for books and single users, we have them protected. So that means that we are not exposing this as our API. We are only using that in the insert user method, that for purposes of overriding, we still need to have that as defined as open in Kotlin, because by default the method will be final. So if we have this, then we can define our insert user with books basically as two single operations. First insert the user or insert the books, and then insert the user. One last thing that we need to do is make sure that this runs in a single transaction, and this can also be done by Room by annotating this method with add_transaction. So the result of this is that Room will generate the code for everything that's abstract, so for the insert single user and for inserting the books, and it will actually override your insert user function to make sure it runs in a single transaction. And this is very powerful. Yeah, so on the slide also has the example for finding the user, but yeah, consider this, consider making abstract DAOs, yeah, to extend things that you otherwise couldn't do. Right, so that was data access objects and entities. Let's tie this all together. So for tying all of these things together, we need to specify a database class. And a database class is, again, an abstract class. It needs to extend from room database, and you annotate it with the @database annotation. And in that annotation, you specify what entities you want to use in your database. So basically, tells room what tables to create. It also specifies the version of your database, which is important when you're starting to migrate data. So as your app evolves, you're bound to add some more properties to your entities or add some more entities, and the version is used to make sure that you have some kind of trigger to know what the version of the existing database is and what the version is where you want to go. So in that abstract room database class, you also specify methods to get your data access object classes. And again, these are abstract, and room will generate an implementation for that. And then you need to find some way to have a singleton of this database class at runtime. So depending on how you approach this, you can use Dagger, for example, and inject it. You can also have a singleton instance like I did on the slide. But the important part is that you only want to have one database class for your application, because you basically, in SQLite, you're only allowed to have one single connection, otherwise you'll mess up your database. So you have one database class and multiple threads accessing the database, that's fine, but you can't instantiate multiple databases. That's a setup for disaster. So once we've done this, we can get our database, we can get the data access object for it, and then just do a query, right? We just call this get me all users method. So when we do this at runtime, we'll get this error at runtime, so your app will crash. It will say, I cannot access the database on the main thread since it may potentially lock the UI for long periods of time, which is totally true. And actually, this is a good thing. Like, Room is now protecting you for doing stupid things, and it's crashing your app, and basically telling you, nope, we're not going to query on the main thread. Because, yeah, it was actually never okay to do database operations on the main thread, but I guess we all did it. We cheated. So there is some good news and bad news here. So the good news is that for queries, Room provides some methods to get off the main thread, basically. But for instant delete and update, there is nothing provided by Room yet. I hope that they will. But it basically boils down to that you have to run your operation in an async task, RxJava, Kotlin coroutine, or whatever you can think of. Room doesn't really care and doesn't provide anything for you. For testing only, please promise for testing only, you can allow the main thread queries by setting that on the database builder. But yeah, again, it's a big problem if you're doing I/O on the main thread and want to have a performant app. So one approach that you can take for doing this async stuff is, again, you can use an abstract database data access object. In this case, we have a base class, and well, this is not the full base class, of course, but it's just a generic class where we have a function to insert some objects. I made the synchronous one, which would run on the main thread. I made that protected, so nobody can call it, basically. And then I called that same function in a Kotlin coroutine. And then you can just override or extend that base data access object class and run your insert in a coroutine in this case. And well, you can do multiple variants of this. You can do this with RxJava as well. It will just be the same thing, just add a method to your base class and make sure that you call that instead of the sync variant. For queries, it's a little bit simpler. Room provides observable queries, which are by default async. So there are two ways to do observable queries. One is using live data, which is also another architecture component, which is pretty nice to use. It's tied to a life cycle, so you know that it won't be accessing databases when your app is not alive, basically. The other option is using RxJava. If you're already using that in your app, Room provides an artifact to interface with RxJava. And it's nice because not only does it deliver async updates, results, it also gives you updates. So if anything changes in these tables, then the live data will emit the new result set. And same for RxJava. So if you specify, if you just change your method definition from a list of users to live data of users, then it's already observable. And if you want to use RxJava, you just change that to flowable. For RxJava, you can even use single and maybe. In that case, they won't be updated, but will still give you this, this async behavior. So once you have that set, using live data, it's pretty simple. You just on create, you just observe that data, and once that data comes in, you do something with it. So that's pretty easy. Type conversion. So Room needs to have a way to convert fields that it doesn't know about, like simple types like strings, ints, to something else. These type converters can be scoped to fields, to entities, to databases. So there's really a lot of options to pick from. There are no default converters, however, which is kind of unfortunate. It would be nice to have standard converters for date or enums. This is how you write them. You just annotate a method on a static object with your type converter annotation, and then you say, well, this is how I convert a date to a long, and how I convert a long to a date. So that's pretty easy. And like I mentioned, you can scope these. So if you want to say, well, for this entity only, for this specific field, I want to use these set of type converters, then you can. You can also say, well, for this whole entity, I want to use these type converters. But generally, you probably want to use your type converters on your entire database so that the dates are converted in the same way, depending on, for every entity. And what's also nice about this is that these type converters will also work in the method parameters. So you can now pass in a date, and you don't have to know that this is actually stored as a long in your database, which is quite elegant, I think. So if you have more complex objects, you could write a type converter that does something funky and squashes all your fields into a string, for example. But it's much better to use the embedded annotation. And what the embedded annotation does is will basically flatten all the properties of the objects that it's embedding into the table. So in this case, we have a user and we have an address. If I specify embedded on the address, the user table will now have a street, house number, and city column as well on there, which is convenient because now you can query for all users that live in a certain city, for example, by a simple SQL query. And if you have an embedded object which has an embedded object which has an embedded object, it will just flatten down all these embedded properties all the way to the top, and we'll basically expand the table, the user table in this case, with more columns. Let's see. So migrations. I mentioned a little bit about migrations already. When you're adding, deleting, updating, removing entities, whatever, there are bound to be some schema updates. So the data that is stored in your app, at some point you need to do something to migrate it to a new version. And it's dependent on a database version number that I mentioned on the database class. And the migration is basically a class that makes sure that you take your database from version X to version Y, basically. If you are missing a migration, then Room will crash your app, which might sound bad, but what they did before is they would wipe out all the data, which is actually worse, I think, because now you were mistakenly pushing out some update. Your app will just happily remove all of your users' data, and your users will be angry. Now you at least have the chance to fix your mistakes, add the proper migrations, and everything should be fine again. So creating a migration is pretty easy. You just have a class that specifies from which version you're migrating and what is the target version. And then, which is kind of inconvenient, then you're on your own. Then you have to figure out how to get the database into a state that Room likes. So if you have added columns, then it's your job to execute the proper SQL statements here to add that column. If you added indexes, indices, then it's also your job. And if you don't do your job right, then Room will just crash on you. So it's kind of inconvenient that in other places Room will give you a lot of help in validate queries, but when you're doing migrations, you're pretty much on your own. So to specify what migration you have, you just add them on the database builder, and Room will figure out which ones to run. So you can have migrations from version 1 to version 5 and from version 2 to version 3 or whatever. Room will just figure out which ones to run and will run them for you. And this is where these exported schemas come in. And these schemas contain all the information that Room has generated for you, and it also allows you to basically peek into that files and see what kind of statements is Room using to create these tables. So in practice, you'll probably be saving these files to version control as well, and then you'll know how to write your migrations. And then your only option is to write some tests to make sure that these migrations actually work. And there's a good chapter in the documentation on how this testing works. If you don't care about migration, if you're merely using your database as a cache, you just set the fallback to destructive migration option, and it will just wipe out your database when it doesn't has the proper migrations. So what's nice about databases is that you can store enormous amounts of data. But getting that out efficiently is kind of a problem. We used to do this with cursors and cursor adapters, but turns out they have some issues. There's a great blog post here what these issues are. So Room integrates with the paging component for that. That's another architecture component, and it takes care of basically having a smart list that will only call back into your whatever paging provider you have to get the data as needed. So going into paging is kind of out of scope for this, but it's important to know that Room will generate the sources for your page list here. So if you have this query which returns a list of users, that might be way too large to fit in memory. So if you want to have that paged and more intelligently used in your app, you can just change that declaration to return a tiled data source. And that data source will then, you can feed that into a page list, and yeah, it will be more efficient. And we also have a variant here that will notify the page list if data changes, like the live data, and that's called live paged list provider. So there's documentation on how this all works and how you need to, what plumbing you need to do for the paging component as well, but this is the important part. Yeah, so I have a couple of things to go over quickly. Room has a couple of features that are very nice, but I can't go in fully now. There's foreign key support. Foreign key support is pretty handy if you want to do some data validations, or if you, for example, I have a user with books. When I delete the user, I probably want to delete the books as well. Well, there's a foreign key annotation which allows you to specify this relationship. What's also interesting is that Room isn't directly calling the platform SQLite implementation. There's actually a support SQLite database implementation that allows for alternative implementations to be plugged into Room or any other ORM that's out there. I think there's already one for SQL Cipher, which allows you to have an encrypted database. So that's pretty cool. That's this kind of odd relation annotation. I say odd because I mentioned that we are not allowed to store all these relations, that Room doesn't do it, but there's still this annotation which you can set on a POJO only, so not on an entity, which will then eagerly fetch the relationship from the database. It's kind of complicated how it works, in the sense that you need to make sure that your field is mutable and that kind of stuff. But if you really think you need that support, then it's there. It also has a great testing support, so there's pretty good documentation on that in the Room documentation. So yeah, wrapping up, Room is a full-featured persistence library. I think it makes mostly the right choices when it comes to abstraction and also ease of use. Migrations could use some work. I hope they do some things to generate migrations, for example, or have some kind of automatic migration in the future. But as it stands now, it's a pretty capable library. It works pretty good with Kotlin. There are some rough edges here and there, especially if you use, for example, if your entities are separate modules, there are some known issues, but they're working on it. And it has some great integration with other architecture components and RxJava too. So in particular, it has integration with live data and with the PagedLists. So that's pretty great. If you want to learn more, I really recommend you to check out the documentation on Room. It's a good read. It might be a little bit behind with the Java doc, so it's probably a good idea to look into the Java doc as well. And I especially want to call out for Rina from the Google team, which she has done a couple of talks on Room already, and she also wrote a couple of very nice blog posts with tips, for example, on using abstract DAOs and other tips for Rooms, which you really should read and check out. And that's all I have on Room. So thank you very much for that.
Do you have any questions in the audience? Live questions? No? Okay.
First, there are some questions here. Room versus Realm, which one is better? Okay. I'm not going there. I mean, there are different technologies. It kind of depends on what you need. As always, it kind of depends. I think Realm is easier to store full relationship object graphs basically in Realm. But on the other hand, there used to be some issues with threading in Realm, so it kind of depends on what your needs are. I think it's nice that Room provides a standard solution provided by Google, something that you'll know that's around. There are no additional native libraries, for example. So yeah, I think that's probably a good default choice. Second question, is there a way to encrypt SQL database? Yes. So by virtue of that SQLite compatibility library, you can plug in things like SQL Cipher. Can an app run multiple databases with Room simultaneously? Yes, you can. You can just have multiple database classes and mix and match. You can have the same entities in two databases. You can have separate entities in separate databases. Anything goes. What are the benefits of Room over DBflow? I honestly can't really tell you in the sense, I know that DBflow has some lazy fetching and that kind of stuff, but other than that, I don't have enough experience with DBflow to tell you. So I think Room is a little bit closer to the metal in that sense. It's doing less magic compared to DBflow, but also gives up the lazy loading for that reason. What about migrations? Is Room shipped with tools to help and manage that? Well, no. That's basically my biggest complaint. So I'm not here to plug my own framework, but what Cupboard did was basically figure out, oh, there's a new column, let's just add it as a migration. Because 9 out of 10 times this is what you want to do, right? You have your table, you have some old data, new column comes in, just add it. So it would be nice for Room to have something like that, either in code or maybe from Ender Studio to figure out how to migrate that data. And all the information is there in terms of those JSON files. Everything is there. So my expectation is that they will use those JSON files eventually to generate some migrations for you. Have a great day. Yes, I'm having a great day. I'm both enjoying Kotlin and Prague, so thank you. What about entity inheritance? Yeah, you can inherit entities as far as I know. So if you have like a base entity, you can do that. Yeah, this works. Same, what about removing columns in a migration? Yeah, sure, as long as you do it. I mean, it's kind of, the pragmatic way is probably, for me, the pragmatic way is that just to keep the column in place. Because on on SQLite, you can't really delete a column. You can alter a table to add a column, but you can't really remove a column. So in practice, yeah, does it really matter that your database now has this column for some users? Well, if you care about that, then you need to copy the table and copy the table data. If you don't care about it, you just add the column and forget about it. Yeah, so that would be my solution to that. And I saw a boom, but yeah, boom. No more questions, thanks.